Ever had your Python program crash unexpectedly? That dreaded red text in your console? It's frustrating, right? Programs crash because of errors, also called exceptions. When an error hits, your application can break, leaving your users confused and your data potentially messed up. No fun. But what if I told you there's a superhero in Python that can gracefully handle these errors? Meet try and accept. They're your powerful mechanism to make your code robust and user-friendly, no matter what unexpected input or situation comes up. By the end of this video, you'll master the try, accept, else, and finally blocks and learn how to write code that doesn't just work, but works reliably. Let's dive in. All right, let's start with the basics. What are errors and exceptions in Python? This will cause a syntax error. Print hello. First, you have syntax errors. These are like grammar mistakes in your code. Python catches them before your program even runs, like forgetting a closing parentheses here. This will cause a zero division error at runtime. Result equals 10 divided by 0. Then we have runtime errors, also called exceptions. These happen while your program is running. For example, trying to divide by 0 or trying to turn text into a number when it's not a number. So why handle them? Well, imagine your user types something wrong. Without error handling, your program just crashes. Game over. With error handling, you can give them a friendly message, let them try again, and keep your application running smoothly. It's all about user experience and program stability. Now, for the core of it, the try except block. Try, code that might cause an error. Print, trying something risky. Accept, code to run if an error occurs in the try block. Print, an error happened. The try block is where you put the code that might cause an error. If an error occurs inside try, Python immediately jumps to the accept block. If no error happens, the accept block is completely skipped. It's like saying, try this, but if it fails, do that instead. Try, num equals int, hello. This causes a value error. Accept value error, print, that was not a valid number. Accept zero division error, print, you can't divide by 0. You can be specific about which errors you catch. It's usually a good idea to catch specific exceptions like value error or zero division error. This way, you only handle the errors you expect, letting unexpected issues surface for debugging. You can even have multiple accept blocks. Try, some risky operation, result equals 10 divided by a. Accept exception as e. Print, if an unexpected error occurred, e. What if you want to know what the error was? You can capture the error message using accept exception as e. The e variable will hold the details of the exception, which is super helpful for debugging. Try, num equals int, input, enter a number, accept value error, print invalid input, please enter a number. Else, print f you entered num, no error occurred. Next up, the else block. This code runs only if no exception occurred in the try block. It's perfect for code that should execute when everything goes smoothly. Try, file equals open, my file txt, r, read file. Accept file not found error, print file not found. Finally, this will always run whether there's an error or not. Print, attempted file operation complete, closing resources. File close. In a real scenario, you'd close the file here. And finally, the finally block. This code always runs no matter what. Whether an exception happened or not, whether it was caught or not, the finally block executes. Think of it for cleanup tasks like closing files or database connections, ensuring resources are released. Here's a full diagram showing how try, accept, else, and finally all fit together. It's a powerful flow for robust code. Enough theory. Let's get our hands dirty with some live coding. Open up your favorite Python editor. First, let's see a crash in action, causing a zero division error. Print, starting division, num1 equals 10, num2 equals 0. Result equals num1 divided by num2. This line will cause an error. Print f result result. Print division complete. If we run this, boom, 0 division error. The program stops right there. Now, let's fix it with try except, handling 0 division error. Try result equals num1 divided by num2. Print result. Accept 0 division error. Print error cannot divide by 0. Please provide a non-zero denominator. Print division attempt complete. See? No crash. We get a friendly message and the program continues. Much better. Let's try another common one, value error when converting input. Handling value error for user input. Try age star equals input. Enter your age. Age equals int age star. Print f, you are age years old. Accept value error. Print invalid age. Please enter a whole number. If I type ABC here instead of crashing, it tells me invalid age. What if multiple things can go wrong? You can chain except blocks, handling multiple specific exceptions. Try num star equals input, enter a number. Divisor str equals input, enter a divisor. Num equals int num star. Divisor equals int divisor star. Result equals num divided by divisor. Print result, result. Accept value error. Print error, please enter valid numbers. Accept 0 division error. Print error, you cannot divide by 0. Accept exception as E. Catch any other unexpected errors. Print an unexpected error occurred E. See how we handle both specific issues? And that accept exception as E acts as a general fallback for anything else. Now let's bring in else and finally. Using else and finally. Def safe divide A, B, try, result equals A divided by B. Accept 0 division error, print division by 0 is not allowed. Return none. Else, print division successful. Return result. Finally, print division attempt finished cleanup phase. Print safe divide 10, 2. Print dash times 20. Print safe divide 10, 0. Print dash times 20. Safe divide 10a. This will still crash if not handled by a general except or specific except for type error. Notice finally always runs, but else only runs when there's no error in the try block. The last case, 10 divided YA, still crashes because we didn't explicitly catch type error there. This highlights why catching exception as E is useful for unknown errors. Let's quickly talk about a few common mistakes. Mistake 1, catching too broadly. Try some code. Result equals 10 divided by 0. Except too broad, this catches everything. Print something went wrong. Using a bare except, this catches every single error, even syntax errors or keyboard interrupts, which can hide real problems. Solution, always try to catch specific exceptions. It gives you more control and clarity. Mistake 2, not user-friendly feedback. Try int oops, accept value error as E. Print E. This prints the raw Python error. Not giving user-friendly feedback, just printing the raw Python error message isn't helpful for users. Solution, provide clear, simple messages like, please enter a valid number. And a quick one. Mistake number 3, putting too much code in the try block. Only wrap the specific lines that might cause an error. This makes your error handling more precise. Let's put everything together by building a simple command line calculator that's robust against bad input. Robust calculator project. Def calculate, while true, print simple calculator. Print operations, plus, minus, multiply, divide, type quit to exit. Operation equals input, enter operation. If operation.lower equals quit, print exiting calculator, goodbye. Break. If operation not in plus, minus, multiply, divide, print invalid operation. Please choose from plus, minus, multiply, divide. Continue. Go back to the start of the loop. Try num1 str equals input, enter first number, num1 equals float, num1 star, using float for more flexibility. Num2 star equals input, enter second number, num2 equals float, num2 str. If operation equals plus, result equals num1 plus num2. Elif operation equals minus, equals num1 minus num2. Elif operation equals multiply, result equals num1 times num2. Elif operation equals divide. If num2 equals 0, raise zero division error, manually raise for consistent handling. Result equals num1 divided by num2. Else, this block is mostly for safety after the initial check. Print an unknown operation error occurred. Continue. Print result num1 operation num2 equals result. Accept value error. Print error invalid number input. Please enter valid numerical values. Accept zero division error. Print error cannot divide by 0. Accept exception as E. Print an unexpected error occurred. E. Please try again. Call the calculator. Calculate. See how it gracefully handles non-numbers, division by 0, and even invalid operations? It keeps looping and letting the user correct their mistakes without the program crashing. This is the power of error handling. All right, time for your challenge. Modify our calculator. Can you add error handling for an invalid operation symbol, e.g., if the user types x instead of plus, minus, multiply, or divide before it gets to the numerical input? Think about how you'd check for valid operations. Hint, you might not even need a try except here, but rather an if statement, which is also a form of input validation. For those eager to learn more, custom exceptions. Look into how to create and raise your own custom exceptions for very specific errors in your application logic. Logging. Instead of just printing errors, explore Python's logging module. It's essential for larger applications to record errors to files or other systems. Context managers with statement. This is a really cool concept, often used with files. It automatically handles setup and cleanup, including error situations. It's a perfect bridge to our next lesson. So, what did we learn today? You've learned that try attempts code, except catches errors, else runs on success, and finally always runs for cleanup. This makes your Python programs resilient and much more user-friendly. Remember, robust code means happier users and more reliable applications. Error handling is a cornerstone of good programming. And speaking of reliability, next up, we'll dive into working with files, read-write. Error handling is absolutely crucial when dealing with files, like if a file isn't found, so your new skills will be put to immediate use. Don't forget to like this video, share it with your coding friends, and subscribe for more Python tutorials. All the code snippets, a challenge, a quiz to test your knowledge, and key takeaways are linked in the description below. See you in the next one.